So I just wanted to give you some context about GSA. We are basically the federal developer for USA. Anything in the federal government besides bases. For the Pacific Rim, we cover Arizona, California, Hawaii, all of the Pacific Islands. Design excellence. So nationally, design excellence is in all of our buildings. We have over 370 million square feet of space that we manage or design. We also house 1.1 million employees, whether they're judges, Customs and Border Protection officers, federal office workers. When you look at these guiding principles we established in 1994, really it's about bringing the best of American architecture to reflect what the United States is about. Oh, goodness. When we look at design excellence, it's also, the key is sustainability. When I was thinking about what people were talking about, we started the design of this project in 1999. Sustainability wasn't, as I call, fashionable back then. It was a word that people didn't understand, especially for when we're looking at workplace. As Javier said, now it's become rote. People talk about site context, how the pedestrians see the building, how the people that live in the building see it, how the building is seen from freeways, from highways. I just wanted to show a couple of things about how we do sustainable development. Calexico, California. It's 80 acres that we did in 1997. We started in 94. 80 acres, this is the land port of entry, and it was all about sustainability in 94 because we had to be self-sustaining. There was no water, there was no way to get electricity. We had to be self-sustaining as an inspection agency. But we also had to be welcoming to our adjoining country, which is Mexico. You know, that's about the thing, the struggle as being the federal government is that we're trying to do enforcement, but we're also trying to be the symbol of being welcoming. So these are just some shots of that development in 3 years, and we're talking about $40 million, right? So it's still always being constrained within the confines of what we have for taxpayers' money. Sandra Day O'Connor Courthouse, 1995. This was about why in the world are we putting a glass box in the desert where it's 110 degrees, you know, in the summer. But this was about creating, that glass box is a transitional space. It's outdoor space for the public to use. So that when it is 110 outside, it's 85 inside this space. Because for the desert, for in Phoenix, that's actually quite comfortable. Now to San Francisco, which is what we're here to talk about. The challenge has always been, for those of us in the Pacific Rim and GSA in general, innovation and sustainability. What does that really mean? And what we're struggling with, we've always struggled with, is that this is congressionally mandated projects. It's money that we need to prove that it's taxpayers' money. What are we doing? Because these are all public spaces. San Francisco, urban context, but also San Francisco, you know, I was born and raised in San Francisco. It's a pretty provincial city in terms of architecture. When we went to city planning for this project, the director of city planning hated this project. He said, you will never build it here. But when we went to the public hearing, because of what we did with the neighborhood people, when we're looking at pathways of where there were green and open space, when we look at how we decided to build the building where there were major transportation hubs, because there was no public parking in this building. When we came to that final hearing to get approval, we had all of the neighborhood groups actually having to come. There were 80 people that came to the podium in support of our project, even though the head of city planning thought it was, what he said, this is the ugliest building that I could see right adjacent to a Beaux-Arts district. So those were our challenges for this project as an owner. When we look at the goals, again, as we said, they were about how it reaches the community, what does it provide in terms of architecture. Really, it was also the innovation of the workplace. This is truly about building a building and asking our clients, well, what do you want? You want natural light, you want to be able to open your windows. Gee, I would love to have a view. Urban contexts, as I had said before, again, we are at the gateway. If you've been to San Francisco, we are at the gateway of the Civic Center. But we're also at the gateway where the district is transformed back down to, in terms of height, 3 stories, 3 to 5 story limit. So we were struggling at how would we actually meet that challenge. Here's just a layout of what we finally came up with. As I said, we're different facets. We have a daycare center, we have public services like Social Security, and this is a federal office building. This just gives you the aerial of what it is today in terms of creating that open space where we can have concerts, or whether food trucks can come into that graveled area. And you can see where the high-rise section is part of San Francisco, and actually we're transitioning down into the lower industrial and maybe residential area. So here, I want to turn it over to Eui-Sung to just talk about the design. But again, for the federal government, it's about the vision of what we're trying to do. And again, this is taxpayers' money, and where we're looking to do always, when I speak, I always say we build for 100 years. If you go to Washington, D.C., if you go to any of our federal buildings across the nation, it is about that permanence. And they are buildings that belong to you. So with that, I'll give it over to you.
Thank you, Maria. When we began this project, and I think I've done bigger, more complicated buildings, but no building actually defined an ethos, a value system that's much larger than a single building than the San Francisco Federal Building. Especially in these time and ages when I think it's extraordinary for the federal government to actually appraise itself as the leaders of a larger value system that will actually drive the culture of engineering, space making, and the good of the community way beyond just a singular structure. So we began with this project, and I'm going to discuss this in terms of its larger urban context, and then kind of bring it internally into the building. The building was meant to actually be extremely didactic. It was meant to actually to demonstrate the most, at that moment, the most progressive values and performative assumptions made by engineers. This was designed to actually be completely sustainable in the sense of the most minimum reliance on mechanical energy. The 2 facades that you just basically saw reflects the diverse southern response and the northern response that the building ultimately would evoke in terms of its responses to climatic context. Speaking from an urban point of view, the building was actually seen as a larger block, but for the sake of where the morphology and the geometry of the building would actually service a larger agenda, it became evident that we could actually kill multiple birds with one stone, which is by keeping a very slender bar at 60 feet wide, we could also explore a strategy where we could actually open up a larger urban plaza that would actually, in respect, pay back to the Ninth Circuit Court of Appeals, the building that was actually renovated by SOM. And at the same time, allow the building to retain and to advocate for its similar profile. And so with this kind of larger urban context, and by anchoring that, and by allowing the building to be a catalytic component to revitalizing the Mission Street neighborhood, the building began a long march in terms of not only demonstrating its civic presence, but also its engineering prowess at the same time. So the building is simply an L in section. And within this, it encases a variety of federal departments, actually 20 of them, that were all dispersed, just like the New York Times narrative, all dispersed across San Francisco. And as we all know, they are all vulnerable to incredible volatile market forces. So to bring them all under a much more of a stable family by the GSA. And the whole telling component of this building is this section. It's like I said, 60 feet wide. And if you zoom in, the main component is actually what we call the upturned beam. So we had a long discussion on trying to rely on a larger choice of concrete over steel for the thermal mass capacities, but at the same time to turn it upside down so that the exposed ceiling was actually the structural slab, and actually to profile it in the way that you see it to actually accommodate a larger cross ventilation wind path. And so here I'm showing you a construction, and if we zoom in, you can see actually the scalloped edges that was designed to actually not only distribute the light, but also to actually create air channels for the wind to go through. And part of the larger kind of metrics, as we all probably know in this room, is that the first 20 feet from the glass is actually the critical level. That's where basically temperature and humidity are somewhat more volatile. California codes allows only the zone 20 feet from the window to be naturally ventilated, so we had to be extremely conscious of that. But back in 2001, when CFDs were really difficult to get by, we were able to actually do so and to kind of vet out the larger performance of the ceiling. And so by having this system going through, the building was able to do a night purge at nighttime because it would actually talk to the satellites from NOAA, do a night purge, all the windows would open up, all the hot air would be evacuated, all the cool night air would come in and then cool the thermal mass. And by having a series of basically different apertures that was both manually controlled as well as building management controlled, you were able to kind of mediate this tension between what the system required the performance of the building to do versus basically the comfort of each one of those occupants. So here you see now this before and after. Again, the concrete, because we went with the thermal mass performance of the concrete, we had to make sure that there was actually larger agendas that was actually a positive toward a larger sustainability narrative. And that had to do with the 50% slag in the concrete. And on top of that, we exceeded the GSA baseline for the use of recycled materials by another 12%. So here's some pictures before and after where you actually see the concrete. These are huge shear walls at the end that are clad by basically this larger stainless steel performative skin. This was actually a 314 marine grade, 3 millimeter. And the price of having no mechanical system was actually now just basically budgeted toward the skin. And the skin went through a series of extraordinary tests to vet it out. And here you actually see now a view toward the double skin. Here are views of basically the insulation. Again, before and after of the primary structure versus basically the final cladding. And here now this is actually just before the tenants moved in. This is actually toward the north where we had actually the milky glass fins. And here at one point you see now the larger integration between basically the profiled exposed concrete ceiling with the series of brise-soleils. And this is actually the view toward the south. So this is actually the stainless steel mesh that looks solid from the outside but is highly transparent from the inside out. And again, just as a reminder of the section. And if I were to flip basically the building from the section to the plan, one of the larger ethos that we were trying to pursue was the inversion of the traditional management being given basically the window seat and then the staff being given the inside. So we inverted that. And by doing that, all the open plan offices were, quote unquote, got all the window seating. And of course, all the management got the inside. That also allowed that profiling and the layout actually was highly amenable to the cross-ventilation strategy that we actually had. And again, these are views through the mesh, so you could actually see how kind of clear they were, even though it was actually blocking out 50 to 52% of the sun. And then if I were now to kind of segue into a narrative about the larger circulation, kind of linking these larger public spaces in, I began with basically the lobby, which at a height of 5 stories was actually linked to the height and to the court. And again, this was done through right after 9/11, so everything had to be beefed up. as you go in. The light was actually much more mediated. It was much more of a cathedral-like entrance. But by the time you get up, there's actually a sky garden at the top that you could actually now enjoy. All these are completely open to the public. You could go right now, and you could actually go up. The 1% of the art was given over to James Turrell as part of like this light show. And ultimately, I'd like to basically kind of conclude the discussion of this building vis-a-vis basically the larger efficiency of the vertical circulation. The Department of Health and Human Services wanted to promote walking. Now, back then, everybody thought that was crazy. Now, everybody has a little Fitbit, and we're all trying to do 10,000 steps a day, right? This would have been ideal if that thing actually came in right now. And so now we actually introduced a skip-stop elevator where with only 6 stops, 6 stops was being serviced by 5 dedicated elevators. So imagine basically the efficiency in that. So that's a diagram. This is actually the section right through the middle of the building where I'm cutting through these 3-story high sky lobbies that are the lobbies for each one of the stops. If I were to zoom in, this is what the section looks like. Once you get off, you either go 1 level up or 1 level down. Don't worry, there is a dedicated elevator for basically the UPS delivery man and the handicap. But once you get off, these are now these 3-story high sky lobbies. And this is now the bottom end of those 3-story high lobbies. Every time you want to use one of the stairs to go up or to go down, you are greeted by a very generous landing, which is reflected in those bay windows, which of course, it further is an homage to the bay window vernacular architecture in the Bay Area. And so these are now these moments of collective kind of spaces that we thought was essential for the larger welfare of the workplace. I'd like to just also kind of be remindful of the fact that the government and GSA and Maria was highly, highly progressive and visionary and courageous to actually have this building to kind of demonstrate a large series of basically best practices. And one of them was an incredibly dedicated BIM set of drawings and modeling that actually would inform everything. So these were done all back in 2000, 2001, at the very, very early stages of computational data management. And here we were taking pains to actually model everything and have a larger management system. And all that data went, of course, to the factories. All the steel was actually galvanized, so they were all bolted on the side. They were not welded to actually maintain a high level of consistency and standardization. And here I'm just basically showing you some of the images. At the end, it ended up saving basically equivalent to the city of Sausalito in terms of the houses and the energy. And in terms of the amount of carbon dioxide that was actually protecting. And so I leave you with some of these lasting images where, again, the building came in as a complete one-to-one integrated, symbiotic, didactic language that would demonstrate basically the larger performance goals of basically the government. And at that time, the most progressive ideals of sustainability that was possible. So I'd like to basically conclude that Maria and the GSA basically still to this day for me demonstrated what the government purpose was to kind of be the leader in terms of the integration and the larger value-driven agenda that the government should uphold on behalf of its citizens and what you and I are supposed to do for our community. Thank you.